can deal with in numerical methods in a numerical methods course. And so we will try to look into some of these matters today. So let us just start our discussion today. I guess you can see my lecture slides. So today we will begin directly with some examples. The previous class we learned about if, else, nested if, and the class before that we learned about how to write our loops. So today I will try to introduce you to some of the common problems that are often asked in different interviews as well. If you go and in your some exams, competitive exams as well, to figure out some algorithms to solve some particular problems where you have to deal with some numbers. Okay, so the numbers, by numbers I mean that have you heard about the words like palindrome number, Armstrong number, words this kind of numbers? Special numbers like prime numbers, they are also special numbers, and they have some particular property, some particular logic associated to their structure. So in the last class we tried to figure out if a number is prime or not, right? If a number is a perfect square or not. So proceeding in the same line, let us talk about some problems where I don't only need the entire number, like for seeing if a number is perfect square or not, you just need the entire number and need to check that if it is a perfect square or not. But there are some numbers where you need to see this number digit by digit. Okay, so all the digits of a number you need to break it down and you need to store it as a list, and then you have to analyze each and every number. For example, palindrome number would be something where 1, 2, 3 to end to begin with. But tell me if a number is palindrome or not, then you have to check that digit by digit, right? So let us talk today about these kind of problems where we have to extract digits from a number and we want to work with them. Okay, so let us start our discussions with those kind of problems. So in this particular case where I need to extract term by term, what I need to do is convert my number into a string. Okay, so string simply means like it's a do you know what is a string and how it is different from a number? String, have you heard the word?
Ma'am, it is a combination of characters.
It is a combination of characters. It's quite close. The definition is something like that. So that means that you just it is kind of a word could be called as a string also, right? If it is just a if you treat it as a combination of like some characters are arranged side by side, okay, something like that. So in these particular problems, what we want to do is we want to take a number and we want to convert it to a string, and then we want to take each of these digits one by one and store it as an array, and we want, or a list, and we want to perform our operations there. So let us just simply jump into one of the problems and you will understand, I will guide you through, you will understand step by step that how a problem can be solved here. So let us directly start dealing with one example where just like the previous case, I will give you one number and you need to check if it is an Armstrong number or not. So what are Armstrong numbers? These are numbers where the sum of its digits raised to the third power is equal to the number itself. Okay, so that's a very, very special kind of a number where the sum of its digit raised to the power of 3. Okay, so that means suppose I have 153. It's an Armstrong number because 1 cube plus 5 cube plus 3 cube is equal to 153. So that's a very, very special kind of a number. So you take 1, 5 and 3 separately and you cube them and then you add them, you get back that number. Okay, so the definition is clear, I guess. Okay, so suppose now I give you a number and ask you that if this number is Armstrong number or not. So you have to write a code that detects that determines that if this number is Armstrong number or not. So what should be the algorithm? So the algorithm would be something like this. Let me just guide you through the algorithm for the first one. Next one you will do. Okay. So I will take the number input. That is the first step. Okay. I will convert that number into a string. That means I will convert this number, whatever I have, to an arrangement of some characters where they will be arranged side by side. Once I make this a command called str will do that for me. Okay, this command str will do that for me. I will do that and I will extract the characters of this string who are basically now the individual digits of this number. Okay. Once I take these characters out, I will use this command eval to again convert them back into numbers. We call them evaluating the digits. So in a more technical word, it will be calling that it will be called as evaluating the digits. So you extract them from the string one by one, and then you evaluate that what is the value of that particular character, and you will evaluate the digits from it. So simply speaking, you will extract that digit from it. You will again convert them into numbers, and then you will run a loop to sum over all the numbers that you have to do, right? You don't know how long this number is going to be. This could be a 5-digit, 6-digit, 10-digit number. So I have to run a loop to add this plus that, plus that, plus that, and all, right? So I will run a loop to sum over the cubes of the digits, and then I will compare the sum with the number with an if statement. Okay. So is the algorithm clear? Should I explain it once again? Take the number input, make that into a string using str, extract the characters of the string one by one, and then evaluate using eval. I will evaluate the digits, and then I will run a loop to sum over the to perform the summing operation, this summing operation. For that I will need a loop, and then I will compare the sum with the number. Okay, so this is the strategy we are going to take. So there are different this kind of special numbers present in our number system, and if you want to any number is such that you want to break it down digit by digit, this is the strategy. Up to these first 3 steps you have to follow to extract the digits and evaluate the digits once again to get the numbers back. Then you perform whatever that special character that particular number has. Here you are summing over cubes, somewhere else you will be doing something else, and then you will compare it to see if the number is that kind or not. Okay, so let us see the code. Let me just guide you through the code. So testing an Armstrong number. Okay, so the logic is each of these terms raised to the power 3 should give me after summing should give me back the number. So what do I do? First step, I take the input of the number, or you can simply write the number here. You can ask the input from the user. The first line, you are already very familiar with that, so not explaining that. So whatever input the user gives, or whatever value, you can simply write 153 here, num is equal to 153. That value gets stored into this variable num. Okay, this variable is again a variable name, up to you, whatever name you want to choose for it, you can give that. Next step, convert it to a string. So converting to string, okay, converting to string, str num. Okay, str open close is the command for converting it to just an arrangement of the characters. So now it is not a number anymore. Whatever you will give to the system is just some characters sitting side by side. Okay, so we do that. We convert it to a string. Okay, it is not a number anymore here after this. So n is not a number anymore. It is just a string where those numbers, those digits are just arranged side by side. Okay. We know that we have to do a summing operation, right? So we initiate our sum. We initiate the value sum as 0. We know that. We have already discussed this several times, right? So whenever we have a summing operation, we initiate it as 0. Whenever we have multiplication like operation, we initiate it at 1. Okay, to make sure that extra addition or extra values don't get added, any junk value does not get added. Okay. Next, I start the for loop. So that is what my algorithm tells me, right? Now I have converted it to string. Now I will do the for loop to perform the summation. What I will do? What do I want to sum? I want to sum all the characters of this string after converting them into numbers. Okay, so what do I write? I write for I in n. Okay, so for I is the counter in n. That means the length of n will be taken here as the range, right? Then k is equal to, I define a new variable, k is equal to eval I. Okay, so that means each and every serial number of this particular string one by one will be taken, 1 2 3 4 5, that is how it will go. How long the string is, that far it will go. And each of these terms, so in first step the first digit, in second step the second digit, in third step the third digit will be taken out of this string and they will be evaluated. Okay, so in the first step, the first digit will be taken out of the string and it will be evaluated. That means it will be again converted back to a number, and then we sum it up. Okay, then we sum it up. So here the command that I have written is basically what we write, sum is equal to sum plus k cube. We write that, right? When we do the summation operation, it is a simpler way to write it. So this writing plus equal to means add with the previous value of sum, add this new value. Okay, so what was the previous value of sum? Sum was equal to 0. Okay, so sum plus equal to k cube means evaluate the value of I, that is the first digit, take a cube of it and sum it with the previous value of sum. So previous value of sum was 0. So say my number was 153. Okay, the same example that we had. So let us consider that my number is 153. So the three digits of this number that I have is 1, 5 and 3. So after this step, this n is basically an arrangement of 1, 5 and 3 sitting side by side, which does not mean 153 anymore. Okay, now here I evaluate them one by one. So the first step, the first digit is taken, the first digit of this string is taken, and then it is cubed and it is added to whatever the previous value of sum was. So now it is 1 cube, that is 1. Okay, again for I is equal to 2, it runs and the second digit is taken, evaluated, cubed and summed with the previous value of sum. Now the new value of sum was 1 cube, so 5 cube gets added to it, and similarly 3 cube gets added to it. The limit is given here, so it stops and it comes out of the loop. So just note the tabs, note the colon sign here. Okay, so this is how the loop runs. So after the loop is done, I am done with performing the sum of the cubes. I am done with that. I am done with performing the sum of the cubes. Now this variable sum basically contains this 1 cube plus 5 cube plus 3 cube. This entire thing has been summed inside this this variable that I have defined before as sum. Okay. Now the last step is quite simple. You have to check if it is an Armstrong number or not. That means you have to compare it with the initial input that you took. So initial input is still stored inside num. We have not destroyed that. Num is still containing the initial input because the entire operation we performed with n, that is the string, right? So num is still 153. So I start comparing it. If sum equal to num, okay, equal to for comparison. If these two values are exactly equal, then print that this number num is an Armstrong number. So what will be printed here? Instead of num, the value of number will be, value stored inside this variable will be printed, and then whatever is inside code will be printed intact. So you will have 153 is Armstrong number. Something like that will be printed on your screen. Okay. Else print 154 is not Armstrong number. Okay, so if these two are not equal, then this statement will be printed. So this is kind of a perfect example of how you combined for loop operation and along with your conditional operations together to check if a number is a particular, obeying a particular relation or not. So just look through the code once again and tell me if you have any doubts. Okay, fine. Okay, so you will take your time and write this code in your Colab. Be careful about Python 3 or Python 2, okay? And you check if this code works for other Armstrong number. You can Google for other Armstrong numbers and check if it is working or not. Or I'm giving you another another example for another number. So this is a list of Armstrong numbers, okay? So you will get different Armstrong numbers. You can check, okay? So let us talk about another set of numbers which are called strong numbers. So strong number is something where the sum of the factorials of each of the digits are equal to the number itself. For example, 145. So in case of 145, you have 1 factorial plus 4 factorial plus 5 factorial is equal to 145. So a similar problem, right? A similar problem that we have solved right now, exactly a similar problem. Instead of cube, now you have to compute factorial term by term. Okay, so this I am giving you as a home task. Try to solve this problem and let us try to find out the strong numbers between two limits. So suppose I give you two limits between 1 to 10,000. Which numbers are strong numbers? Okay, so I want to have a code like that where we will go through all the numbers starting from 1 to 1,000 or 10,000, and you will check for the for these strong numbers. You will only print those numbers which are strong numbers. So at that part, I am making the code a little bit different. Previously, we were just getting an input from the user and checking if it is a strong Armstrong number or not, right? This time, I want you to go through all the numbers between an interval and check or print only those numbers which obey this particular property. So is the question clear?
Yes, ma'am.
Okay. So what will be the algorithm? Who is going to tell me what is the what will be the algorithm for this? How many loops and how many conditions do I need? Think about it. Think about it. Take 1 minute. Think about it and tell me.
Ma'am, 2 for loops.
2 for loops. Very good. And 1 condition, right? Okay. So why do I need 2 for loops? Because I don't have a single number this time, but I have to check through a range of numbers, right? So I have to check through a range of numbers, and to go through all those numbers, I need a for loop to begin with, to choose my number, to pick up my number. Once I pick up my number, I do the same steps. That way I have code converting it into a string, and then taking out the digits of that string, again with factorial, and then I will sum it up and compare the sum with one of the numbers from this range, right? And I will again go back and take the next number from this range. So that is why I need another for loop. So is it clear that why I need 2 loops here, and what will be the structure of the code? Anyone has any doubt about it? You can go ahead and ask, no problem. We can discuss this once again if you have any doubts. Fine. So you can write this code, right? So go ahead and try to write this code. I'm not giving you the code. So here is an output, kind of an output that I wish to have from the code. Okay. So you have to print strong numbers, and then you print the list of the numbers. Take a range, say 50,000. Okay. So 1 to 50,000. What are the numbers which are strong numbers? So interestingly, you can see 1 and 2 are both strong numbers. And the next comes at 145, and then the next comes at 40,585. So you can see that how they are separated by long intervals. Okay, so try this out, try this code out, and try to generate an output which looks like this. Okay, so try to mimic whatever is here. Try to mimic that in your output. Exactly this thing should come out as your output. So push your code, push yourself to get an output exactly looking like this, with all these tabs and all these enters, like new lines and everything. Okay, make sure that everything comes. So it should not be like 1 sitting on top of 2 and then 1, 4, 5, and we don't realize that which number is which one. Okay, try to make these new lines printed in your output. Okay, fine. So we discussed a little bit about this kind of a type of a problem, right, where you have to pick up the digits and check. So an obvious example in this scenario, in this kind of problems, is obviously palindrome number. And let me just tell you another way to deal with it. Check if your number is palindrome or not. So as I said, the example in the example before, that palindrome number is basically when you read it from first to last and then you read it from last to first, you get the same number. Okay, so here I want to use our list manipulations that we have learned. Okay, we have learned about lists, how to append a list, how to reverse a list, and things like that. So we can write palindrome numbers code in the same way as well, the way we have just learned. We did that, right? So you can use the same methodology to write a code to figure out a number is palindrome or not. But because this palindrome has a very simple property that if you read it from first to last and last to first, you have the same number, we can use our list manipulations and reverse the list and check it very easily, right? So if I can convert it to a list and I can reverse the list and I compare these two lists, then that will be a much simpler problem to solve, right? So this is the trick we are going to use here. So we already know that in a list, these are the serial numbers, right? So first digit in a list was 0, then 1, 2, 3, 4, and backwards this was -1, -2, -3, -4, -5, like that. So the serial numbers of elements in a list are basically specified in this way. So let us try to convert our number into a list and and solve the problem of palindrome number from there. Okay, so to solve the problem that is if a number is palindrome or not. So palindrome is some word or some number which, if read from the opposite end, appears to be the same. So it has a reflection symmetry, so to say. Okay, reflection symmetry. Say this is the number, so it has a reflection symmetry from this middle digit. Okay, so let us. So what will be the algorithm for this? So using list manipulation, we will do something like this. So we'll take the input of the number. Okay, I will convert that number to a string. Then I will reverse the string using our list manipulation techniques, and then I will compare these two strings. Okay, so I don't have to compare term by term, but I can do compare with the entire list by just reversing it. So how will the code look like? Let me show you the code. So you take the input of the number in the first line. Okay, you take the input of the number in the first line, you convert it to a string. Okay, you convert it to a string. Then we do this command. Okay, just check this out. This is basically manipulation of a string, and you considering it to be a list. Okay, so what are you doing here? We have equated the string converted version of num in n. Okay, and now I am treating n as if it is a list, and then I am writing something like colon -1. What does it mean? Okay, what does it mean? Let me just explain what does it mean. So it simply means that we are trying to extract a slice of the list. Okay, and this is the list. Here whatever you write is the list, which was n in our case. Here you write where to start. If you don't write anything, it starts from the very beginning. Here you write where to end. If you don't write anything, it will by default end at the very end of the list. Here you write the interval. If you don't write anything, it will take an interval of +1. Okay, so that's simply, let me just give you an example here. Suppose this is my string converted number. Okay, there was a number and then I have converted it to a string. So this is just an arrangement of these 5 digits. If I write n 0:2, okay, so the first whatever is written just before the first before this colon, the first colon, whatever is written is basically start. So it tells you that start from 0th position. This is the 0th position. It is indicating you to start from the 0th position. Okay, and then end. Yes.
Ma'am, we are not able to see the slides.
You are not able to see the slides.
No, ma'am. It's blank. Screen is blank currently.
Why? How far have you seen? The last slide you are able to see?
We saw till the examples of strong numbers. After that, not this what you are discussing right now.
This you cannot see. Okay, so let me just. Is it the problem with everybody?
Yes, ma'am.
Yes, ma'am. I have the same.
Yes, ma'am.
Okay, why is that happening? Let me just try to share once again. Can you see my screen?
No, ma'am.
Yes, ma'am. Now we can see.
Now you can see. Maybe some network problem. Slides. Can you see?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. So what I was trying to say here is how to write the palindrome numbers code, right? So here you can see that this number n is equal to something I have written, right? This is basically converted version of a particular number, converted to string. Okay, so this number has been converted to string. This quotation marks indicate that this has been converted into a string. Now, if I write n0:2, okay, if I write like that, that simply means that it has to start from 0th position, which is this 0th position, right? We know that in Python the counting starts from 0. So we start from the 0th position. We go till the second position. Second means 0, 1, 2. So this is the second position. We go up to this. And there is no colon afterwards. That will definitely mean that the interval is 1. Okay, so the structure is something like this, that you mention the list start, end, interval. Okay, so whatever is before this first colon is the point where you have to start. Whatever is between, that means the point where you have to end. And finally, there is the interval. So the default value of start is at 0. Default value of end is at the very end of the array. And default value of interval is 1. So if we don't write any intervals precisely, then it will mean that you slice the list with an interval of 1. So what does it mean? So if I write n0:2, that means, again, following our rule of Python, it will be starting from 0, like here. It will print 7, 3, and then it will stop right before the end. So end is never reached in Python. Even in for loops, we have seen that. So it will not go till 4. It will stop right before that. So it will print 7, 3. Okay. If I write n::, okay, that means we have not mentioned any start point, any end point, or any interval. So that will print it intact. So start is by default at 0, end is by default at the very end, and interval is 1. So it will print 1, 1, 1. Now if I print ::2, then what will happen? From start to end, it will go, but it will skip one term at a time. Okay, so it will print the first one, then skip the next one, then print this one, and skip the next one, and then print this one. So it prints 7, 4, 2. So can we understand this? This is slicing of a string, and this is sometimes very useful while dealing with these problems related to these numbers, this special kind of numbers. So do we understand this? Just check the commands once and just tell me if you understand this. Okay. Any doubts? Fine. Okay. So, so in case of checking out if it is a palindrome or not, what we do is we write we convert it the number to a string, okay, and then I write n colon colon minus 1. So what will that mean? That means it will take it's from the start to end, but the interval is -1 means that it will reverse the entire list. Okay, so it will reverse the entire list. So this is the command that is important. This is the trick that we do to avoid a writing a long code for checking a palindrome number. You can obviously do it turn by turn, but we don't do that. We just reverse the string and save that value to a new variable m. Now you can use any of these if statements, any of these if statements to print that it is a palindrome number or it is not a palindrome number. So here you please check out that this is the symbol for indicating not equal to. Okay, this is the symbol for indicating not equal to. So we know that inside if which put double equal sign for checking if it is equal to, greater equal to, less equal to. Now if we want to check if it is not equal to, then you exclamation sign followed by equal to is meant as not equal to inside the if condition. Okay, so this code you can try, and the trick that is being used is this. Okay, so these kind of tricks are common in Python, and you can use them whenever you want. You can just Google through different already introduced codes and modules, and you can figure out these nice little tricks which can actually squeeze the size of your code a lot. Okay, so this is it with the numbers. So before concluding today's class, I will talk a little bit about iterative series. So are we okay with the numbers? All the problems that we have solved with the numbers? Fine.
Ma'am, in string, is it also like list? Like once we modify with the list, we cannot get the original list back. We have some command for that. With like the same way, the string it is also same.
Here, that is why I have equated it to m, right? So I have equated this to a new list, new string, which is m. So n is intact, n is kept intact. If you write n is equal to this, then it will be completely gone. Okay.
Okay.
So inside a script, if I have assigned a new variable called m and to store this reverse value, that keeps my n intact. If I don't do that, then n will be destroyed. If you store it on top of n, then it will be destroyed. Okay.
Okay.
Okay. So let us move on to one final problem that I want to discuss, and that is related to series. So I already discussed that using for loops you can solve several infinite series problems, like figuring out what is exponential of x, figuring out what is sine x, cos x. Just with the use of the infinite series, you can use a loop, you can use an iterative sum to figure out how to calculate the values of, say, sine pi by 2 or sine cos pi by 2 or something like that. Okay, so a similar problem comes when we deal with other iterative series like Fibonacci numbers. So Fibonacci numbers are a series of numbers. I guess that each of these number in the list is the sum of two previous numbers. Okay, so if you check out, this is the list. So the first two digits are 0 and 1, and we start with that. So 0 and 1, so we add it, we get 1. 1 plus 1 we get 2, 2 plus 1 we get 3, 3 plus 2 we get 5, 5 plus 3 we get 8, and so on. This is how the list grows. Okay, so in this kind of iterative problems, what you need to figure out is the rule that how do you define any term in this series? What do you need for that? And then you go on appending this new number to your previous list. Okay, so this is the thumb rule of any of these iterative problems. So when you have a relation where the one term of a list is related to the previous terms of the list, what you need to find out is how they are related. What is the mathematical relation? How you can write term number n plus 1 with respect to term number n. So once you define the iterative rule, you can write your code. Okay. So for Fibonacci numbers, it is quite simple that a particular term, say a n plus 2, series number n plus 2 is always a sum of a n and a n plus 1. Okay. So term number n plus 1, when you sum them up, you get term number n plus 2. When n could be anything. N is an integer of this list. N could be anything. N could be 0, 1, 2, 3, whatever you want. Okay. So if I ask you to write a code where this kind of an iterative series will be printed, so what will be the algorithm? The algorithm is you take the initial numbers, you have to take them, it's 0 and 1, you have to start with those numbers. Then I want to have a loop, a for loop, right? Where we obtain the third number as the sum of first two numbers. Now I have to update. What should be the update? My second number should be now considered as my first number, right? My third number has to be considered as the second number, and I have to sum them again to get the number of the next number of the list. So that simply means that I start with 0 and 1. I sum them up to get 1. Once I get 1, in my logic, I replace wherever 0 was stored, I replace that with this value. So I store this in here and I store this in here. And the same rule repeats. Okay, so this now instead of 0 and 1, 1 and 1 gets added. In the next step, I get 2, right? And then I take this value and I give it here. And I take this value 2 and I take it here. And again, I just sum up these two values. Okay, so let us check out the code. You will understand it better if I write it in Python. You will understand it better. So Fibonacci numbers, okay, iterative series. How to print all the numbers one by one on your screen. So I start by assigning n1 and n2 two numbers, the first two numbers of the list 0 and 1. You can initiate them in a single line that we know, right? Comma separated. You can introduce them. You can initialize these two numbers. Then in the next step, I write n3 is equal to n1 plus n2. So n3 is the third number of the list. I write that is equal to n1 plus n2. That is straightforward, right? The next term. So next term is here. Okay. Now what I do? Now I make a list of n1, n2 and n3. Okay. I define a list. F, you can name it whatever you want. I define a list where I have these numbers n1, n2 and n3. Okay. Then I start my loop. What do I do inside the loop? So how many numbers do I want? Up to how many terms we want to print? That will be my range. Okay, my range will be how many numbers do I want to print on the screen finally? How long my series should go? So I define a counter k. So for k in range, say 1 to 10, I want to do this thing 10 times. Okay. Then what do I write? I write n1 comma n2. So what was n1 and what was n2? 0 and 1, right? Is equal to n2 comma n3. So n2 now is 1 and n3 now is 1. I replace this previous value of 0 and 1 of n1 and n2 using these new values of n2 and n3. So after this step onwards, my n1 is 1 and my n2 is also 1. n1 is 1 from here because n2 was 1 before. So that value of n2 gets assigned to whatever value was in n2, that gets assigned to this new to this variable of n1, and whatever value is stored in n3 gets assigned to this variable of n2. So is this step clear? That is the most important step of this logic that we are doing. Okay, redefining the terms, reassigning the values of the terms. Then I again do the same thing. N3 is equal to n1 plus n2 because now n3's value I have already stored in the as a variable of n2, right? And I now just sum it up and append this new value to f. So now this new value of N3, though it is actually the fourth term, I still name it N3. You can name it like the new term, right? So the new term comes after that and my list grows. Once my list grows, I again do the same thing. I again do the same thing and redefine the terms. So this goes on. This goes on 10 times, and that is how 10 more terms get printed on the screen. Once you are done, you come out of the loop. So up to this point, there was a tab. The tab is gone after this point. Then you print the entire F. Now the F is appended, right? All the new N3 values in each step, you find a new N3 value, and that value gets appended in the list. 10 more terms come, and you print that on the screen. Okay, so take your time to absorb, to understand what we did here and what was the main trick that we did. Okay, so try to appreciate this, that what kind of a problem is this and how we can solve this kind of a problem and other iterative series as well. Okay, so any questions here? You understand it clearly? Any doubt anywhere in this particular code? Okay. Okay, so try this out. Write this code in your machine, in your Colab, wherever you are practicing. Write this code and try to understand and appreciate each and every step of it. Okay, so I will stop here for today. These are quite some examples. So try to get an output of this code. You should get something like this as you go on printing the Fibonacci series. You should get an output of something like this. So try to get that and try to achieve this output. Okay, and I'll stop here, and this up to this point would be our syllabus for the internal assessment. So that will cover the basic mathematical operations, defining new functions, calling or importing new modules, basic list operations, loops, conditional statements, and problems with a combined version of all these things like series, numbers, and solutions, which we did in between and which we also solved in today's class, along with whatever sir has covered till Monday. Okay, sir will cover till Monday. That will be included in the exam. So any question about the exam? Actually we will be mailing you the question sheet, I guess, and you have to mail it back to us within time. Okay, something like that, a structure would be there. Do you have any queries about the exam? Okay, then I will stop here for today then. And if you have any doubts, you try these codes out. You try to write some of your own codes as well. And if you